All right, so picking up where we left off, we were on number 2 right here, dealing with this number line. And so now we're on this true or false question. When a value is raised to an exponent, the value will always increase. So that's a statement that we're given, and we're asked to determine if that statement is true or false. All right, well, let's think of a couple examples. Okay, so when we think of an exponent, keep in mind that exponent, that's always when we have a big number, let's say maybe 3, and then a little number up here, let's say 2. And so that 3 to the second power will be the same thing as me saying 3 times itself 2 times. So writing out 2 3s and multiplying them together. So this would give me 9. So the question is this number, just the 3, always going to be smaller than the new number, the 9? When a value is raised to an exponent, that value always increases. So in this case, we went 3 squared to give us 9. Okay. Well, what if we do something else? What if instead we do 3 to the first power? Okay, so I raised it to an exponent. So let's see that change value over there. So 3 to the first, that's going to be 3 times itself once, which is just going to be 3. There's only one 3. There's certainly nothing we're going to be multiplying. So in this case, 3 did not increase, but it stayed the same. Okay, so this sentence we've already proven to be false right off the bat. Okay, let's look at another example. What if we keep going down a power? So we went for the second power, the first power. Now let's go to the 0 power. Well, 3 to the 0 power, well, that one is a little bit different. So let's type that in the calculator and see what happens. 3 to the 0 power gives us 1. So anything to the 0 power will give us 1. So again, because of that, 3 did not increase. It became 1. So again, we've proven this statement to be false. Okay, so one way we can kind of analyze this is that provide an example to justify our reasoning. So the answer is false, and then we could say exponent must be greater than 1. Okay, so the exponent has to be greater than 1 in order for that value to increase. Okay, it went from 3 to 9 because the exponent was at 2. All right, next up. For number 3, which relation has the greatest value if x is evaluated at -1? Justify your reasoning. Okay, so another way to think of this question is we're going to look at each one of these representations of data, and we're going to either plug in for x equal -1, or we're just going to look at where x equals -1, and we're going to see which one has the greatest y value that is associated with that. Okay, now some of these things might be a little bit unfamiliar to you, okay, and we'll get into these a little bit deeper later on as we go through the class. Okay, so this first one, we have a graph. Okay, so in a graph, we have these two main lines, and these two main lines are known as my x-axis and my y-axis. Okay, so these are basically just number lines. Okay, so the x-axis is a number line that goes from left to right, kind of like these up here that we were dealing with. And then the y-axis is another number line, but instead of going left to right, it goes down to up, to where the negative numbers start down here and they get positive as we go up. Okay, so if we want to figure out where x is equal to -1, so we start on our x line. Okay, so one thing to note, where these two axes meet, this point right here, this is going to be the point 0, 0, okay, where x is equal to 0 and y is equal to 0. This is going to be the 0 on both of our number lines. So if we want to go back to where -1 is, well, keep in mind that -1 is just one spot away from 0. So that means that at this line right here, this is the line where x equals -1. So this is where x equals -1. So now we're going to look at this graph. So we have this graph right here, and we need to basically ask ourselves, where does this graph cross this dotted line? And it is at this point right here. That's where the graph crosses the dotted line. So now we need to look on the y-axis, okay? Because the y-axis is another number line that as we go farther up, the values increase, okay? So this is 1, 2, 3. And as we go farther down, they would go in the negative direction, -1, -2, and negative 3. So if we look, when x is at negative 1, y is at 2. So for this graph, the y value is going to equal 2. Okay, so again, we're looking through each one of these representation data and seeing which one has the highest y value that is associated with x. Okay, all right, so next up, x is at negative 1 for the table. So we just look for where we have in the x column negative 1, and that is at this point right here. So when x equals negative 1, y equals negative 6. Okay, this next word right here is mapping. Okay, so mapping isn't something that we're going to see a whole bunch, but mapping is kind of similar to a table in that we have two little columns. We have an x column and a y column. And instead of them putting it in a row like this for us, what they instead do is they have all the x's and then they draw an arrow to the y that corresponds with that x. So again, we're looking for where x equals negative 1. And so we're just going to follow its arrow to wherever it draws to, okay? So the negative 1x corresponds to y equals negative 1, okay? And then lastly, we have an equation, y equals negative x plus 3. So for this one, what we're actually going to have to do is we're going to have to plug in negative x and then solve for y. That's what we're going to do. We're going to solve for y after we plug in x. All right, so let's plug it in. So y is going to be left alone. This negative sign is part of the equation, so we're going to write it first, then put my parentheses. Anytime I plug a number in, put parentheses. Now we're plugging in negative 1 for x, so we'll put negative 1 in there, close it, and then add plus 3. So y will equal negative 1, which will be positive 1, plus 3. So y will equal 4. Okay, so now the question is, which relation has the greatest value if x is evaluated at negative 1? So basically, which one has the biggest y value? We have y equals 2, y equals negative 6, y equals negative 1, y equals 4. So that's going to be our biggest value. All right, so next up, we have a coordinate system. So we saw this in the last example. We saw it with the graph. So that graph is actually going to be called a coordinate system that's formed at the intersection of two number lines. Okay, these two number lines are, again, the x-axis and the y-axis. Okay, and in these things, we can plot different little points all over the place, and these points are also known as ordered pairs. Okay, an ordered pair is a set of numbers written in the form of x, y. Basically, we can use any combination from this number line and this number line to figure out a destination. Okay, so a couple key things to point out. Okay, so this arrow is pointing again to the intersection of the two axes, and this point is the origin point because it is where this whole plane originates at. And so this origin is also at the point 0, 0, because I don't have to move anywhere going left or right or anywhere going up and down to get there. All right, so let's answer these questions. What is the scale of the x-axis? So basically what it's asking is between each tick mark, how much are we jumping? Okay, so on the x-axis, this is the one that is going from left to right. We can see right here, the number's a little bit faded, but we go 1, 2, 3, 4, 5, even if we go in the opposite direction. Negative 1, negative 2, negative 3. So each time we're only jumping 1, because even this little dot right here, that little dot represents 0. So we're going negative 3, negative 2, negative 1, 0. So the scale of the x-axis, how much are we jumping between each tick mark? So the scale is going to be 1. All right, so now it asks us, what is the scale of the y-axis? Well, if you notice, the scale on the y-axis is a little bit different. It seems like the tick marks are a little bit more spaced out. There's not as many of them on this side. So let's look. So the numbers, again, a little bit faded. So we have 2, 4, 6, 8. We go in the other direction. Negative 2, negative 4, negative 6, negative 8. So each tick mark, we're not jumping 1, but we're jumping 2. So the scale of the next one will be 2. All right, so now back to this little quadrant. So this quadrant is divided into 4 little segments, and these segments are known as quadrants. Okay, quadrants, that's just a fancy word we use for them. Okay, and so we number these quadrants 1, 2, 3, 4 with Roman numerals, and we start in the top right. So this is quadrant 1, okay, with Roman numeral I, that represents 1. This is quadrant 2, quadrant 3, and quadrant 4. Okay, so we start in the top right, and then we rotate counterclockwise. We rotate to the left. So next up, in which quadrant would you find an ordered pair where x is greater than 0 and y is less than 0? Okay, so what they're really asking us is where would we find a point where x is positive and y is negative? So we need positive x but negative y's. Well, if we look on the x-axis, the only way for me to get a positive x means that I have to be to the right of 0. That's where my positive x values lie. So that's going to take out 2 and 3. So now, in order to get a negative y, well, if I go up along the y-axis, I have positive values. But if I go below 0 on the y-axis, I have these negative values. So the only place for me to go to have a positive x and a negative y is going to be quadrant 4. All right, next up, on the coordinate plane, graph the ordered pair -5, 4, and label it as point A. All right, so graphing this ordered pair, okay, so keep in mind, ordered pairs are always of the form x, comma, y. So whenever it gives you two numbers, the first number tells you how far along the x-axis do you need to go from 0, and then the second number, how far away on the y-axis do you need to go away from 0. Okay, so whenever we plot a point, we always start at 0. And so first number is -5, so that's going to tell me I need to go -5 on the x-axis. So to go negative, I'm going to go to the left, and I'm going to go 1, 2, 3, 4, 5, and this is going to be that point where x is -5. And now from here, I need to go up 4, okay? Because in order for me to get +4 for my y, I need to go up into the positive direction. But instead, keep in mind that we're counting by 2s. So when I go up a tick mark, that's at 2. And this right here will put me at 4. Okay, so this is going to be the point -5, 4. And I'm going to label that point A. Okay, we've got 2 more examples. What is an algebraic expression for the word phrase 32 increased by the square of a number? Okay, so this is some stuff that we saw a couple sections ago in interpreting a phrase and turning it into a mathematical expression. Okay, so we have 32 increased by. So 32 increased by, that tells me that 32 is going to get bigger. We're going to give something to 32 that's going to make it greater. So I'm adding something to 32. And now this right here, terminology may be a little bit unfamiliar to us, the square of a number. Okay, so when you think of anything that is a square, something squared, so anytime we have just a number, we know that's our x. And if we have the square of a number, that's always going to imply that we're raising something to the second power. Okay, so anytime you hear the square of a number or a number squared, we're always going to assume that is to the second power. All right, now we got a couple questions. How many terms are in this expression? Okay, well, the number of terms is always going to be 1 less than the number of addition or subtraction signs. Okay, so if we look, we have 1 addition sign right here, and that separates our terms. Okay, so we have 1 addition or subtraction sign right here, so that means we're going to have 2 terms in total. Okay, next up, what is the coefficient? So the coefficient is going to be the number that is directly in front of the x squared, but it has to be paired with the x squared. Okay, so if you look, directly in front of the x squared, we don't have any number. So we might be wanting to say 0, but there always is an understood number, and that is 1. So the coefficient that is in front of the x squared, the number that's always paired with the x squared, is 1. Okay, the constant, the number that's by itself, that's going to be my 32. What is the variable? That's going to be what is the letter that we're using. That is going to be x. I'll continue this in video 3.